So hello. It's a weekend and still we are excited to do some questions. Let's go. So this is one interesting question. I just did it like 2 hours ago with some of my mentors, and it was I thought like why not make a video about it. So we have this question like you were given the map of Calakmul. I don't know. Sorry to pronounce it in this word way, but okay. Maya archaeological site in the Mexican state of Campeche. On the main square, there are several buildings. In particular, building 6. We do have wait, this is the building 6, this is the building 4, this is the 8, 7, whatever. The latter is the complex of three towers. It is known that one of looks from building 6 to building ivy on the days of equinoxes and solstices, the rising of the sun. So yeah, I'm just giving you, I mean, in fact our mentor gave this us because if you could just print it, you could just print it out, and with the scale you could just find it. It was not of a problem. We have the scale right here, but it's not printed out. So basically all the things that would have carried half a time for you in IUA is just right there. So basically what we have to calculate is we have to estimate what is happening, yeah. So we have to estimate the towers relative to the observation point. For this we need to be doing a lot of things, just a lot of things. We need to go from the formula related to this, whatever, the angular, what am I talking about? Okay, the declination. Okay, the declination we have to talk about. We have to talk about actually a lot of things. So where should we start? Should we start from a simple formula in positional astronomy? mm, like there are a few concepts that you might need here. I will talk about it. One first concept is, that's not a concept, 10x is height divided by the length. Everybody knows it. So altitude of the sun, whatever, this is the length, this is the height. um yeah, the height of the building. Another formula you need is sine of declination equals sine of phi, sine of x plus cos phi, cos of x, cos of if you, in case if you're wondering what is this cos of x, or what is uh what is this whatever, like uh the capital, the capital A will be, I guess, as everybody knows about it, the capital A is none other than the azimuth, right? And the what do we have it here? Delta is the declination. Del is the declination, phi is the latitude, whatever. So basically, what we are revolving around in here is that we're going to first, what do we need? We need declination, because since we already have been given Yale, which we don't have to actually find out, but if you want you can just find it out from right here, the length. So we have already given the L, that we need, right? We need H, right? And we already will get the altitude, which I will tell you, and what we are going to find is H. So we basically have H as length multiplied by 10 of altitude. Okay, so what we basically need to do is that we have length, the distance, we need the 10 of altitude. So from one formula for equinox. Before saying this, you might have one thing: the northernmost one extreme point will be of the summer solstice plus 23.4 declination. The southernmost will be the winter, which is minus 20.4. So the middle must be an equinox. Try to visualize it by printing this. You can take a screenshot, right? You can take a screenshot. Okay, so what we basically do here is put declination as 0 for the equinox, right? We basically have bottom, middle, and the top towers. So we have been given that azimuth is 14 degrees south, middle, this is the bottom, this is the top, I'm sorry. So bottom is 36 degrees south of east, middle is 14 degrees south of east, and top is 7.63 degree north of east. So keep north as the reference for 0 degree azimuth, and then you can calculate the azimuth for all this. So for the bottom pillar, we have the, what do we call it, azimuth. I mean the solar declination is minus 23.4, top would have plus 23.4, and the middle would have declination as 0 degrees. So now for a declination of 0 degrees, we can easily calculate by just put in 0 right here, it will be sine 0. Okay, so we will have sine phi sin h plus cos phi cos h cos a. Now just sine phi sin h divided by cos phi cos h equals cos a. So it will be tan phi tan h. Okay, it's going to be negative because cos a. So from this actually we have I guess tan h equals cos a minus by tan phi, and you can find the altitude for this. So the altitude, when I put in the values, okay, so the altitude comes as 36.7 degrees. So height will be just this multiplied by this. So yeah, 82, because we have 82 right in here already given. Okay, so 82 multiplied by tan of 36.7, we will have 61.2, because azimuth right here for the middle one is 14 degrees south. So 180, I mean sorry, this one 16 degrees south from east, it will mean azimuth is 104 degrees. Have this common understanding that it is north. We have been given the northernmost part. South, east, west, it has been given what, 6 degrees south from east, this one, right? So just 90 plus 36, what, middle south from east. So yeah, it's the south from east. I guess when you plug in all the formulas, wait, 90 plus 14, it is for the middle pillar, I'm sorry, middle is 14 degrees south from the directrix, 14 degrees, so 90 plus 14 is 104, lol. So yeah, you will basically get this formula, and height of the middle tower you will get 61.2 meter. So again, for the bottom pillar, you see the formula right here, it will be 36 degrees south of east. So this is not going to be in the same attitude, and the declination of course is minus 20.4. Plug in the formulas, I guess minus 20.4 equals sine 18 sin h plus cos 18 cos h cos of azimuth, and we get as 16.5. Therefore L will be equal to 86 meter, because we already have it right here. It has made it so easy. So thus H will be 25.5 meters, because 86, it will be multiplication of 86 and 10, 16.5. Similarly, it goes for the top pillar. Azimuth is 7.63 degrees north of east, so therefore you will have to subtract this. You will get 82.37 degrees, right? And use the same formula. You will get H, and then you already have L as 84 meter above. Therefore you must get it around H top as 76.2 meter. So that was it. This was an interesting question. I just thought it will be really nice if I could make this question and upload it on YouTube. So yeah, that's it for today.